Right, good morning again. Let's look at the homework that you had on page 56. That was the number 1, 2, and 3. So here we have to deal with forces, and objects are in equilibrium. So either moving at a constant velocity or at rest, and how we can draw free body diagrams, force diagrams, and calculate forces when we have this information at hand. Right, so number 1, they give us a tugboat that's pulling a barge along a river at a constant velocity. So they give us the specific information that the applied force from the tug is the 7 kilonewton, and then that the tug applies the tension force. We call that, when it's connected with a rope, two objects with a rope, we call it a tension force. So this is an illustration. I don't do pictures, so I have my tug and I have my barge. When we draw free body diagrams of each object, look at what we have. Remember, I'm moving at a on each object must be balanced. So let's look at our tug first of all. If we have a 7 and we have this tension force, remember that tension force is between the two objects, so the tug is pulling the barge, but the barge is also experiencing. Although it's in opposite directions, it is still 4.5 kilonewton, sorry, it's all in kilonewton, 7 kilonewton. This is the 4.5 kilonewton. So for this object to move at a constant velocity, my forces must be balanced. So how are we going to write this? So if we want to do it according to a formula, we can say, but my net forces equal to 0. This means the sum of all my forces must also be equal to 0. So let's write it in. Let's say F applied plus Ft plus F drag is equal to 0. Have a look. If I do it this way, my applied force, remember direction again, positive. So let's use this as a positive direction. Then this is 7 kilonewton plus my tension force is negative 4.5 plus my drag force, that must be equal to 0, so therefore we can say my drag force is equal to negative 2.5. Is that correct? I hope so. My math shouldn't let me down at this point in time. So drag force is negative 2.5 kilonewton. Okay, so easy enough to find that one. We do exactly the same for the barge. Right, so if we look at the barge, we do again that my F net is equal to 0. My forces must balance out. So we can say Ft plus drag is 0 if this is 4.5 kilonewton plus what is my drag force? Sheesh, but if drag must be equal to negative 4.5 kilonewton. Okay, so the negative just implies in the opposite direction to the motion. Okay, so although easy enough, the way that you write it is important. You have to state that your net force is 0. Therefore, the sum of your forces is equal to 0 and show the calculation. Right, let's move on to our next question that we have. So in this question, we have a boat. What do we have? Sailing boat, sailor, what? Yacht. A yacht moving due north as a result of wind blowing in that specific direction, 40 degrees east of north. They want us to show or calculate the component of the force that is in the direction the yacht is moving and the one perpendicular. So it's my red that I indicated and my blue that I indicated. Now, if I'm just going to use this as is, let's us calculate this. I'm going to say this is again my y component just because it's in my y-axis, and this is going to be my x component. So I'm dealing with AI and II. So let's do f of y. What is f of y? Well, if I look at my diagram and I look at this triangle over there, this one, that is my hypotenuse, this is my opposite, this is my adjacent. So with reference to my 40 degrees given, it's the adjacent side that I want to calculate. So then I'm going to use this equation. Cos theta is adjacent over hypotenuse. Okay, so let's do it. So for I, it is cos of 40 degrees equals my adjacent, which is my fy, taking it in the northerly direction, over my hypotenuse, which is the 350. And now I have fy, and it calculates to, what is it, fy? 268 Newton. Let me just quickly confirm that. So 40 cos times 350 gives me 268 Newton. Right, so using trigonometry. For I, and I'm going to do it in the blue so it corresponds to my picture. Now it is, if that's my blue, then this is going to be that side, so that's the blue. So this is f of x in that diagram. It's the same side. It's the opposite side to my angle of 40 degrees. So I'm going to say sine 40 degrees equals fx, my opposite side to my hypotenuse. And now I can calculate fx. What is fx? It's the sine of 40, which is 0.64, times 350, and that gives me my 224.9 Newton. So we can say 225. Let's just 225 Newton. That's still good with you guys. Okay, so please remember this is my little formulas that I'm using in this case. Alright, let's move on to 2B. They say explain why the crew of the yacht need to lean out as shown below to prevent the yacht capsizing due to the force of the wind. Remember, these forces are going to cause the boat to tilt. It's causing a moment. So the sailors need to apply a force to the other side. Literally like that. So they need to lean out, providing a force to the opposite direction, creating a moment to the opposite direction to prevent the boat from turning over. So they need to create a moment in the opposite direction. That would be an answer to that. Right, let's look at the next one. Number 3. Number 3 is a nice question. And now, immediately when I say nice question, then you need to know it is challenging. So let's have a look at what we have. We have this inclined slope of 5 degrees. Then we have a car being pulled by a truck, and that force is also at an angle. Sure. So now we're dealing with various angles here. We're dealing with angles at an inclined plane, but also angles in an applied force. Now, first question for A, so this is a drawing representing it. It doesn't show all the forces, it's just basically what was given to us. They say calculate the component of the tension in the tow rope parallel to the road and perpendicular to the road. So let me just do it in yellow over here. So they want us to calculate that force, the yellow one, and they want us to calculate this one, the blue. So that's the forces they want us to calculate. So let's just use that drawing. This is an A. I'm going to just bring that drawing down. So here's my force parallel to the road. Here's my force perpendicular to the road. And this is the applied force. There we go. So this was the 580 Newton. This was my 15 degrees. Okay, so 15 degrees and a 580 Newton. Let's see how we can calculate this. So again, I'm going to say this is Fx. How do we calculate Fx? Fx is adjacent to my 15 degrees an hour. So if it's the adjacent one, Fx, it is going to be my 580 cos 15 degrees. You will see I don't have a specific formula, so Fx is always this. I'm using my triangles. I'm using trigonometry. So if I have cos of 15 cos times 580, I get to 560. So this is a 560 Newton force. Is it Newton? It is Newton, eh? Yeah, it is Newton. Fx. What about my perpendicular one? Well, that's my opposite side. So now this one is Fy. Fy is equal to 580 sine of 15 degrees. If I calculate that, that is 15 sine times 580. That gives me 150. Is that correct? I'm just checking myself. That doesn't seem to be correct. I get something much different. 15 sine times 580. What's happening on my calculator? I don't know. 15 sine times 580 gives me 150 Newton. Hope it's correct. Got something different here. No. Seems to be okay. Right, so that's for A. What about my B section here? It says B, calculate the component of the car's weight. Okay, so now we're talking about our weight. Here we have this, that, and that. This is FG parallel to the road, and this is FG perpendicular. Now, as explained, in previous videos. This angle is equal to that angle. So now we have the same thing. We have the same triangle. That angle is opposite, so FG parallel, that is equal to that. That's my parallelogram if you draw it. So let's calculate FG parallel. It's the opposite side to my angle. So FG parallel is going to be FG sine theta. What is FG in this case? FG is that 6.2 kilonewton. Okay, so now I'm going to say 6.2 times 10 to the power 3. I'm just going to calculate this now because otherwise, remember, it's not a ratio anymore. I need to use my full value. And it's sine of 5 degrees. That gives me FG parallel. FG parallel, so what is sine of 5? 5 sine is that times 6.2 exponent 3 gives me a 540 newton. Okay, so that's fine, 540 newton. For my perpendicular one, FG perpendicular, it is the adjacent side. So adjacent is FG cos theta. FG is again at 6.2 times 10 to the power 3, it's a kilonewton, and theta cos of 5 degrees. So FG parallel. Let's do it. What is 5 cos? It's at 0.996, so this value is going to be very close to that. Is times 6.2 exponent 3, and it gives me 6,176 newtons. So that's the perpendicular. So this question breaks it nicely in two. When we have something that is being pulled by an angle, and when we have something that is on an inclined plane. Nice question. Let's deal with our part C. Part C asks, okay, by comparing your answers in AI and BI, calculate the magnitude and direction of the force of friction acting on the car. So this is what we have now. We calculated the force of tension. Remember, we can only work in a straight line. So this was that Fx that we calculated. And this was the FG parallel that we just calculated. We're moving at a constant velocity. So constant velocity means what? It means that my net force around this object should be equal to 0. So my drag force, drag, my friction, so drag, friction. Drag is usually to air resistance, friction is due to a surface. But it's friction. When it's air friction or friction of a surface, drag force, you can use those terms interchangeably. So if I want to do this, the sum of my forces is going to be Fx applied plus Fg parallel plus F drag is going to be 0. Because we're moving up, I'm still going to use that as positive. Fx is 560 plus, this is in the opposite direction, 540, it's negative, plus my F drag. I know you can see the answer directly, but do the calculation. And that is negative 20 Newton. So you got it, it's 20 Newton in the opposite direction. Let's look at the last one of these. In D, they say now, the van's weight is 12 kilonewton. There's my weight. We know what? We know Ft is the tension between my car, the car, and this is the van pulling it. That's that 560 Newton. Remember, Ft is It comes from my Newton's third law. If the van applies a force of 560 on the car applies a force of 560 on the van. So reaction-action forces. I know they don't talk about it in that specific way anymore, but that's what they are. If I lean against the wall with a force of 5 Newton, the wall is applying a force of 5 Newton back on me. It's just an opposite direction. So this is indicated by the arrow. If I want to calculate the force that my engine is applying, I need to calculate now FG parallel for the van, because this is my weight. It's different than the car. Again, I can start from the same point. I'm moving at a constant velocity. Up is positive, up the slope. So my net force is equal to 0. This means that my force applied by my engine plus my Fg parallel, let's say that, plus my F tension is equal to 0. I have my Ft, I can calculate my Fg parallel. Remember in that one video that I made, if we're working with this, because the slope is still at 5 degrees, that's 5 degrees, and we have our triangle there, and that being 5 degrees. So this stays the same. Parallel, sliding down, so we can use sine. So let's quickly add in the values that we have. Engine, this is Fg sine theta, plus what was this? This is the 560, well, it's negative there, equals 0. Let's write in the values again. I'm just going to abbreviate this Fe for the engine, plus this is my 12,000 sine 5. Also, it's moving in the opposite direction, so in essence it is negative. Minus 560. Well, let's do it this way. Then we keep to our rules. Let's calculate that. So 5 sine times 12,000 gives me 1,045. This is 1,045 plus my 560. If I do it like this, so the engine should produce something around 1,605. So my engine should produce a force of 1,605 Newton minimum to move at a constant velocity up the slope. And I think that's what you needed to prove in this. Show that the force of the van's engine must be at least 1.6 kilonewton. And yes, if I want to convert that, this is 1.6 kilonewton, and that's it. Please ask if you have any questions on the group. I will post this as soon as possible.